The data arrived on a Tuesday morning in July 2025. Routine, clinical. Just another asteroid scan from the Atlas telescope system in Hawaii. The numbers scrolled across computer screens like they had thousands of times before. Object designation 3I Atlas. Distance approaching from the outer solar system. Trajectory hyperbolic. Then the anomaly arrived with the morning calibration. Atlas logged a new track, 3I Atlas Interstellar, inbound, active. Photometry showed a faint coma, spectroscopy. Hinted at CO2. Outgassing was real. Over the next 48 hours, astrometry from Atlas, VLT and Hubble refined the orbit. The surprise wasn't the gas, it was the motion. Comets that vent behave like a leaking balloon. The escaping material gives them a tiny shove, a non-gravitational acceleration you can measure if your instruments are steady enough. This time, the shove wasn't there. Within detection limits around 10.8 ms2, the trajectory stayed clean, as if the gas never pushed at all. That single, mismatch visible outgassing with no measurable recoil turned a routine detection into a problem statement. If the gas is real, where is the push? Within hours, observatories around the world turned their attention to this silent anomaly. The Very Large Telescope in Chile, the Hubble Space Telescope, the James Webb Space Telescope, each confirmed what Atlas had found, an object that seemed to ignore the laws of physics. But perhaps most unsettling was the realization that 3I Atlas wasn't just any wandering space rock. The 3I designation told the story. This was the third confirmed interstellar visitor to our solar system, the third messenger from the void between stars, and unlike its predecessors, this one carried a mystery that would challenge our understanding of how the universe works. The previous visitors had been strange enough. 1I Oumuamua in 2017, a cigar-shaped object that accelerated away from the sun faster than gravity alone could explain. Scientists measured its non-gravitational acceleration at approximately 4.9 x 10 to 6 meters per second squared. The physics community eventually settled on outgassing as the most likely explanation, despite the object's unusual shape and lack of visible cometary activity. 2I Borisov in 2019 proved more conventional, a clear comet that behaved as expected, outgassing and accelerating predictably. Telescopes measured its non-gravitational acceleration at roughly 3.8 x 10 to 7 meters per second squared, well within expected ranges for objects of its size and composition. Both visitors had taught us that interstellar space isn't empty, it's filled with wandering objects, each carrying stories from distant star systems. Now came 3I Atlas, and its story was unlike anything we'd encountered before. The object measured roughly 400 meters across, about the size of 4 football fields placed end to end. As it approached the sun, solar radiation began heating its surface, triggering the release of gases. Spectroscopic analysis by the European Southern Observatory revealed carbon dioxide streaming from its surface, along with traces of other compounds. Everything about this process was normal, expected, well understood. Everything except the silence. In physics, when gas escapes from an object in space, it creates what scientists call non-gravitational acceleration, or NGA. It's as fundamental as breathing. Every comet that's ever been studied shows this effect. 9 Oumuamua showed it. 2I Borisov showed it. Even tiny spacecraft feel it when they vent fuel or lose atmosphere. 3I Atlas showed nothing. The measurements from multiple telescopes were precise, repeated, verified. If there was any acceleration due to outgassing, it fell below detection limits, roughly 10 to 8 meters per second squared, an order of magnitude smaller than what should have been easily detectable, given the observed gas production rates. The gas production was clearly visible, streaming away from the object in brilliant displays, captured by the world's most powerful telescopes. Yet the physics that should have governed this process seemed absent. It was as if the object had found a way to expel gas without obeying Newton's third law, as if it could push against nothing and feel no reaction, as if the fundamental physics that govern every other object in the universe simply didn't apply. The scientific community was faced with an unprecedented puzzle. Here was direct, observable evidence of an interstellar object, behaving in ways that challenged basic physical principles. Either our understanding of physics was incomplete, or 3I Atlas represented something entirely new. As July turned to August and the observations continued to pour in, questions began to dominate discussions in research labs around the world. What mechanisms could explain this behavior? What combination of factors might produce such an extraordinary contradiction? The data refuses to behave. And sometimes, when the universe presents us with the impossible, we must examine every assumption we thought was certain. The Gemini South Telescope in Chile tracked 3I Atlas through the southern sky, its instruments dissecting light that had traveled across interstellar space. Each photon carried information, chemical signatures, temperature data, velocity measurements. The story they told was becoming more perplexing by the day. Spectroscopic analysis revealed the object's surface composition with remarkable detail. Carbon dioxide dominated the outgassing, a common enough finding for comets. But the precision measurements began revealing patterns that made seasoned astronomers pause mid-calculation. Consider how a garden sprinkler works. Water exits through multiple nozzles, each jet pushing the sprinkler in the opposite direction. The forces usually don't cancel out perfectly, creating the characteristic wobbling motion as the sprinkler turns. This is exactly what happens when gas escapes from a comet. The object spins, tumbles and accelerates as jets of material stream away from its surface. 3I Atlas was showing all the signs of active outgassing, gas production rates comparable to known comets, clear spectroscopic evidence of material streaming away from the surface, brightness variations suggesting rotation as different regions became illuminated by the sun. Everything indicated an active, venting object. Yet the trajectory remained laser straight. Researchers at the European Southern Observatory spent weeks double-checking the orbital mechanics. The mathematics were unforgiving. If gas was escaping at the observed rates, the object should show acceleration. The equations demanded it. Newton's laws required it. Every precedent in astronomy supported it. The absence of acceleration wasn't subtle. It wasn't a marginal effect that could be explained by measurement uncertainty. The expected acceleration should have been easily detectable, roughly equivalent to what had been measured for other interstellar visitors. Instead, measurements from multiple facilities consistently showed values below detection thresholds. This created what physicists call a null result, when you expect to find something and don't. In science, null results can be more significant than positive detections. They force you to reconsider fundamental assumptions. 3 primary explanations emerged from the data analysis. First, the object might possess extraordinary mass so heavy that the push from escaping gas became negligible. Imagine trying to move a cargo ship by blowing on it through a straw. The forces are real, but the effect is undetectable because of the vast difference in scale. Second, the outgassing might be perfectly symmetric. If gas escaped equally in all directions, the forces would cancel out, producing no net acceleration. Like a balloon with holes on opposite sides, the escaping air wouldn't cause movement because the pushes balance perfectly. Third, measurement limitations, or unknown physical processes, might mask the expected effects. Perhaps the acceleration was occurring in ways current instruments couldn't detect, or through mechanisms not yet understood by physics. Each explanation carried profound implications. The mass hypothesis required 3I Atlas to be roughly 10 times denser than typical comets. Instead of a loose collection of ice and rock, it would need to be a solid metallic object, essentially a flying mountain. While possible, this raised questions about how such a dense object could produce the observed outgassing patterns. The symmetry hypothesis demanded perfect balance across the entire surface. Any slight asymmetry, a patch of different composition, an uneven heating pattern, a small crater affecting gas flow would break the symmetry and produce detectable acceleration. Achieving such perfect balance seemed to require either extraordinary cosmic coincidence or unknown physical processes. The measurement limitation hypothesis suggested that current understanding of outgassing physics might be incomplete. Perhaps objects of this size and composition behave differently than smaller comets previously studied. As August progressed, additional observations deepened the mystery. The object's brightness varied in a pattern consistent with rotation, but the rotation rate remained remarkably stable despite ongoing mass loss. Normally, as a spinning object loses material, conservation of angular momentum causes it to spin faster, like a figure skater pulling in their arms. 3I Atlas showed minimal variation in rotation period. Temperature measurements from infrared telescopes revealed surface heating patterns that matched solar radiation models reasonably well. The sun-facing hemisphere showed expected warming, though some aspects of the temperature distribution appeared more uniform than typical thermal models predicted. Spectroscopic analysis continued revealing carbon dioxide as the primary outgassing component, with water vapor detected in smaller quantities. The ratios fell within ranges observed for other comets, though some researchers noted subtle variations that warranted further study. Each new observation added detail to an increasingly complex picture. Here was an object that appeared comet-like in composition and behavior, yet violated fundamental expectations about how such objects should respond to their own outgassing. The implications extended beyond astronomy. If objects could behave this way, releasing gas without experiencing detectable recoil, it would require revising basic physics principles. The technology to achieve such control, if it existed, would represent advances far beyond current human capabilities. As September arrived, bringing the object closer to perihelion, the scientific community prepared for what additional observations might reveal. The mystery of 3I Atlas continued to challenge everything researchers thought they understood about physics and astronomy. Between silence and anomaly, science hesitates. But sometimes the most extraordinary observations force us to question our most basic assumptions about how the universe works. The James Webb Space Telescope turned its infrared eye toward 3I Atlas in early September, piercing through the object's gas envelope, to examine its surface composition with unprecedented detail. What it found added new layers to an already complex puzzle. Every comet tells a story through its spectrum, the unique fingerprint of light wavelengths it absorbs and reflects. These signatures reveal surface composition as precisely as a medical scan reveals internal structure. JWST's instruments could detect molecular traces at extraordinary sensitivity levels. The initial spectroscopic results confirmed carbon dioxide as the primary outgassing component, consistent with previous observations. However, the detailed analysis began revealing chemical characteristics that raised new questions about the object's origins and composition. Think of analyzing a recipe by tasting the final dish. Even if you can identify the main ingredients, understanding their proportions and preparation methods requires careful analysis. Comets typically display chemical signatures that reflect their formation environments, the cold outer regions of star systems, where different molecules freeze out at different temperatures and pressures. 3I Atlas showed chemical patterns that didn't perfectly match known comet populations. The carbon dioxide appeared with a purity level higher than typically observed in natural comets. While CO2 dominance isn't unusual, the relative absence of carbon monoxide and other carbon-bearing compounds that normally accompany it was noteworthy. This level of chemical separation could occur naturally under specific conditions, but fell outside the range typically observed. More intriguing were trace detections of metallic compounds in the outgassing plume. Spectroscopic analysis revealed possible signatures of nickel-bearing molecules not on the surface, but actually being expelled with the gas. For such metals to become airborne, typically requires temperatures significantly higher than those measured on the object's surface. Researchers at Johns Hopkins University reviewed the spectroscopic data carefully before reporting these findings. The temperature-composition relationship didn't match standard sublimation models perfectly, though several natural explanations remained possible. Subsurface heating, chemical processing during interstellar travel, or unusual formation conditions could potentially explain the observations. The detection of metallic compounds without corresponding ion signatures was unusual but not unprecedented. Some asteroid families show similar patterns due to specific formation or processing conditions. However, the combination with active outgassing was rarely observed. Hubble Space Telescope observations added another dimension to the chemical analysis. High-resolution imaging revealed the object's coma. The cloud of gas and dust surrounding the nucleus displayed organized structures rather than the chaotic plumes typical of most comet outgassing. The patterns were subtle but measurable. Instead of random asymmetric jets driven by irregular solar heating, 3I Atlas showed more organized emission features. Computer models suggested this could result from either unusual internal structure or specific surface geometry that channeled gas. Flow in predictable patterns. Natural explanations for such organization existed. Some comets show similar patterns due to subsurface layering, regular crater distribution, or thermal conductivity variations. However, the degree of organization observed in 3I Atlas was at the upper end of what natural processes typically produce. The gas production rate itself presented another puzzle. Typically, comet activity correlates directly with solar heating. As objects approach the sun, increasing radiation drives higher rates of sublimation, the direct transition from solid to gas. This relationship is so predictable that astronomers use it to estimate comet compositions and internal structure. 3I Atlas showed less variation in gas production than expected for its changing distance from the sun. Its output remained relatively steady, even as solar heating fluctuated, suggesting either unusual internal structure or thermal properties that buffered external temperature changes. Chemical. Isotope analysis of the expelled material revealed ratios that fell within observed ranges for interstellar objects, though some values differed from typical solar system comet populations. The carbon-12 to carbon-13 ratio was consistent with formation in the outer regions of a stellar system, though not perfectly matching local comet families. Water vapor, detected in smaller quantities, showed deuterium content that fell within expected ranges for interstellar ice, though again with subtle variations from local populations. These differences could reflect the object's extrasolar origin or specific formation conditions in its home system. The chemical evidence accumulated into a pattern of an object that was recognizably comet-like, yet consistently unusual in details. Each measurement fell within possible natural ranges, but the combination pushed the boundaries of what typically occurred together. Some researchers began considering whether the chemical signatures might reflect formation conditions different from those that produce solar system comets. Interstellar objects could originate from stellar systems with different compositions, temperatures, or evolutionary histories. Others suggested that chemical processing during millions of years of interstellar travel might alter surface composition in ways not yet fully understood. Cosmic ray bombardment, interstellar dust impacts, and exposure to the interstellar medium could potentially explain some of the observed anomalies. By late September, as 3I Atlas approached its closest point to the Sun, the chemical evidence had revealed an object whose composition raised questions without providing definitive answers. The data suggested either unusual but natural formation conditions or chemical processing mechanisms not yet fully understood. The chemistry of 3I Atlas spoke of possibilities beyond typical experience, yet remained within the realm of natural explanation. Whether those explanations were correct would depend on what additional observations might reveal as the object continued its journey through the inner solar system. What we see defies simple explanation. But sometimes, the universe creates objects that challenge our understanding without necessarily violating natural law. Radio telescopes around the world had been monitoring 3I Atlas since August, listening for any electromagnetic emissions that might provide clues about its unusual behavior. The results were subtle, inconclusive, and deeply puzzling. Most objects in space emit radio waves chaotically. Solar wind interactions, charged particle impacts, and thermal emissions create random electromagnetic noise like static between radio stations, but from cosmic sources. This background radiation follows predictable patterns based on temperature, composition, and magnetic field interactions. The radio observations of 3I Atlas yielded mixed results that tested the limits of current detection capabilities. Several radio telescope facilities reported weak emissions near the threshold of detection. The Green Bank Observatory in West Virginia, successor arrays in Puerto Rico, and the Parkes Observatory in Australia all collected data, but achieving consensus on signal characteristics proved challenging. Consider trying to hear a whisper in a crowded room. The signal might be there, but distinguishing it from background noise requires careful analysis and often yields uncertain results. Radio emissions from 3I, Atlas, if present, operated at the very edge of what current instruments could reliably detect. Initial reports suggested possible periodic variations in the weak emissions, but subsequent analysis revealed the complexity of separating potential signals from terrestrial interference, instrumental noise, and natural cosmic background radiation. Different observatories reported different timing patterns, making confirmation difficult. The SETI Institute participated in the monitoring campaign, applying techniques developed for detecting artificial signals from space. However, their analysis concluded that any emissions from 3I Atlas remained within ranges explainable by natural processes. No clear patterns emerged that met the stringent criteria typically required for claiming artificial origin. Researchers noted that the frequency range of any potential emissions fell within wavelengths that could penetrate planetary atmospheres with minimal attenuation. While this characteristic was consistent with efficient communication frequencies, it also corresponded to natural emission mechanisms from heated materials in space. Some facilities reported subtle timing variations that appeared non-random, but follow-up observations failed to confirm robust periodicities. The apparent patterns could result from instrumental effects, atmospheric interference, or statistical artifacts in the data analysis process. The challenge of radio observation lay not just in detection sensitivity, but in distinguishing meaningful signals from the vast array of natural and artificial radio sources that fill the electromagnetic spectrum. Satellites, terrestrial transmitters, and cosmic phenomena all contribute to a complex radio environment that can obscure weak signals from distant objects. Polarization analysis of the potential emissions yielded similarly inconclusive results. While some measurements suggested organized polarization patterns, the signal strength remained too weak for confident characterization. The uncertainty margins were large enough that natural thermal emissions could explain the observations. The frequency distribution of any emissions appeared concentrated in specific wavelengths rather than spread across a broad spectrum, as thermal processes typically produce. However, natural mechanisms such as synchrotron radiation or specific molecular transitions could also create such concentration effects. Most significantly, attempts to correlate radio observations with other measurements of 3I Atlas's behavior found no clear relationships. If electromagnetic emissions were related to the object's unusual trajectory characteristics, that connection wasn't apparent in the available data. By mid-October, radio telescope observations had accumulated hundreds of hours of data without reaching definitive conclusions. The potential for artificial emissions remained an open question, neither confirmed nor definitively ruled out by available measurements. The uncertainty reflected fundamental limitations in current radio astronomy capabilities when applied to weak, potentially artificial signals from small objects at interplanetary distances. Detection thresholds, signal processing techniques, and interference mitigation all influenced what could be reliably observed. Some researchers suggested that if 3I Atlas was emitting intentional signals, they might be designed to be subtle enough to avoid casual detection while remaining detectable to sufficiently advanced receiving systems. This possibility remained purely speculative, as no evidence supported such sophisticated signal design. The radio monitoring campaign highlighted the challenges inherent in SETI research and the detection of potentially artificial phenomena in space. Distinguishing between natural and artificial sources requires not just sensitive instruments, but robust analysis methods and reproducible results across multiple independent facilities. As the object approached perihelion, radio observations continued, seeking either confirmation of artificial signals or definitive evidence of purely natural emissions. The electromagnetic signature of 3I Atlas remained one of many unanswered questions surrounding its mysterious behavior. The search for signals continued against a background of static and uncertainty, where the absence of clear detection might be as significant as any positive result. The revelation emerged from months of painstaking orbital analysis conducted by teams at JPL, the European Space Agency, and observatories worldwide. As tracking data accumulated, a pattern became clear that challenged fundamental assumptions about how objects should behave in space. 3I Atlas wasn't just failing to show expected acceleration from outgassing. Its trajectory exhibited characteristics that seemed to violate basic orbital mechanics. Think of throwing a ball near a massive object like the Sun. Gravity bends the ball's path into a precise mathematical curve called a hyperbola. The shape of this curve depends entirely on the object's mass, velocity, and the Sun's gravitational field. These relationships are so fundamental that they form the basis for all space navigation. Orbital analysts at JPL had been tracking 3I Atlas's path with extraordinary precision, using the same techniques employed for spacecraft navigation. The data revealed subtle but persistent deviations from predicted trajectories that couldn't be explained by known forces. The deviations were small, equivalent to the gravitational influence of an asteroid-sized object located thousands of kilometers away. But there was nothing there. The phantom gravitational influences appeared and disappeared on timescales ranging from hours to days, following no apparent pattern related to solar heating, rotation, or proximity to other solar system bodies. Multiple independent tracking stations confirmed these anomalies. The European Space Agency's tracking network, NASA's Deep Space Network, and radio telescope arrays on 3 continents all showed consistent results. 3I Atlas was experiencing forces that current physics couldn't explain. The trajectory deviations weren't random. They displayed subtle patterns that suggested either unknown natural mechanisms or some form of active control. Most puzzling was their apparent independence from the object's observable characteristics, rotation rate, gas production, surface temperature, or solar heating patterns. Analysis of the deviation patterns revealed timing relationships that didn't correspond to any known astronomical cycles. The forces seemed to operate according to internal mechanisms rather than external influences, as if controlled by systems unaffected by the object's environment. The energy requirements for such trajectory control would be enormous by current technological standards. Conventional physics offered no mechanism by which an object could modify its gravitational behavior without detectable mass changes or reaction products. Any technology capable of such control would represent capabilities far beyond human understanding. However, natural explanations remained possible. Perhaps the object contained internal mass distributions that created unusual gravitational effects. Maybe subsurface activity generated forces that current models didn't predict. Or possibly measurement limitations prevented accurate detection of conventional acceleration mechanisms. The gravitational analysis also revealed information about the object's internal structure. Mass distribution calculations suggested density variations that were consistent with either natural layering or artificial construction. The core region appeared denser than the outer layers, a pattern seen in both natural objects and engineered systems. The precision of the trajectory measurements highlighted how little was actually known about the physics of interstellar objects. Previous visitors like Mai Oumuamua and 2I Borisov had been observed for relatively brief periods with less sophisticated tracking techniques. 3I Atlas provided the first opportunity for extended high-precision monitoring of an interstellar visitor's gravitational behavior. Some researchers suggested that the observed anomalies might reflect previously unknown aspects of how small objects behave in the solar environment. Magnetic field interactions, solar wind effects, or radiation pressure might create forces that weren't fully accounted for in current models. Others proposed that the trajectory deviations resulted from observational limitations. Perhaps the combination of the object's small size, distance, and complex environment created measurement artifacts that appeared as gravitational anomalies, but actually reflected instrumental or modeling errors. The debate over interpretation highlighted fundamental uncertainties in current understanding of small object dynamics in space. While the physics of large-scale orbital mechanics was well established, the behavior of small active objects under precise observation remained an area of ongoing research. As October progressed and 3I Atlas approached perihelion, the trajectory analysis had accumulated evidence of gravitational behavior that challenged basic assumptions about how objects should move through space. Whether this reflected unknown physics, undetected natural mechanisms, or observational limitations remained an open question. The possibility that the trajectory anomalies indicated artificial control systems couldn't be completely dismissed, though such explanations required extraordinary advances in physics and engineering. Natural alternatives remained plausible, if not fully understood. The gravitational mystery of 3I Atlas forced astronomers to confront the limits of current knowledge about how objects behave in the complex environment of the inner solar system. Some questions might require observations of additional interstellar visitors to resolve. Between known physics and observed behavior lay a gap that challenged fundamental assumptions about what was possible in the universe. Perihelion arrived on October 30th, 2025, marking 3I Atlas's closest approach to the Sun at approximately 1.4 astronomical units. This phase of the object's journey should have provided definitive answers about its mysterious behavior. Instead, it deepened the enigma. As 3I Atlas reached its closest approach to the Sun, observatories worldwide focused their instruments on what should have been the most active phase of the object's passage through the inner solar system. Solar heating at this distance typically drives cometary objects into spectacular displays of gas and dust emission. 3I Atlas reached perihelion and did something that puzzled observers. It maintained remarkable stability. The object's gas production rates, which had remained unusually constant throughout its approach, continued unchanged, despite the dramatic increase in solar radiation. Its trajectory held to calculated predictions without the significant deviations that typically accompany peak cometary activity. Astronomers with decades of comet observation experience describe the perihelion passage as extraordinarily well-behaved for an active object. Most comets show erratic behavior during closest solar approach, as internal heating creates unpredictable gas jets and structural changes. The timing precision of perihelion passage raised questions among orbital mechanics specialists. Analysis of the object's trajectory showed that its interstellar approach vector had brought it to closest solar approach during a specific alignment of inner solar system planets. Earth, Mars, and Venus were positioned such that signals or observations from 3I Atlas's location would reach all three worlds with minimal solar interference. Such alignments occur naturally, but infrequently. The probability of an interstellar object arriving at precisely this configuration was low enough to warrant note, though not unprecedented. Some researchers suggested the timing might facilitate optimal observational conditions rather than indicating intentional planning. Radio telescope observations during perihelion revealed subtle changes in the weak emissions that had been tentatively detected during the approach phase. The basic characteristics persisted, but additional complexity appeared in the signal structure that hadn't been present during earlier observations. The frequency range of potential emissions expanded during perihelion, encompassing wavelengths that could penetrate planetary atmospheres with minimal attenuation. Whether this represented enhanced natural processes or something more purposeful remained uncertain, given the continuing challenges in signal confirmation. Ground-based optical telescopes captured the object's appearance during perihelion with unprecedented detail. Instead of the chaotic, asymmetric outgassing typical of natural comets under intense solar heating, 3I Atlas maintained organized emission patterns that suggested either unusual internal structure or specific surface characteristics. High-resolution spectroscopy revealed that different surface regions emitted different chemical signatures, in sequences that appeared more organized than random solar heating would typically produce. The precision of these patterns challenged standard models of cometary outgassing under solar heating. The chemical composition of emissions shifted during perihelion in ways that didn't perfectly match natural heating models. Instead of the expected increase in simple volatile compounds as solar heating intensified, 3I Atlas began emitting more complex molecules that suggested either sophisticated internal chemistry or previously unknown thermal processes. These molecules included organic compounds typically associated with biological processes, though their presence could be explained by natural chemical evolution in cometary materials. The selection wasn't necessarily meaningful. Similar compounds had been detected in other comets and interstellar objects. Gravitational measurements during perihelion provided additional data about the object's mass distribution and internal structure. The subtle trajectory anomalies that had been observed during approach phase became less pronounced during closest solar approach, suggesting either environmental effects on the measurement process or changes in whatever mechanisms might have been responsible. The apparent reduction in trajectory anomalies during perihelion didn't necessarily indicate artificial control. Natural processes could explain such variation, including changes in outgassing patterns, internal structure or external force interactions as the object moved through different regions of the solar environment. As November began and 3I Atlas started its outbound journey toward the outer solar system, the perihelion observations had provided extensive data about its behavior under maximum solar influence. However, rather than resolving the mysteries surrounding the object, the observations had revealed additional complexities. The precision and organization displayed during perihelion were consistent with either highly unusual natural processes or more purposeful behavior. Natural explanations remained viable, though they required combinations of factors that stretched the boundaries of typical experience. The perihelion passage had demonstrated that 3I Atlas continued to behave in ways that challenged standard models of small object dynamics in the solar system. Whether this reflected incomplete understanding of natural processes or indicated something more extraordinary remained an open question. The visitor's behavior during its closest solar approach had been documented with unprecedented precision, yet the fundamental questions about its nature remained unanswered. Sometimes the most detailed observations reveal not answers, but the depths of what remains unknown. 3 weeks after perihelion, as 3I Atlas began its outbound journey toward the edge of the solar system, orbital analysis teams made a discovery that forced them to reconsider fundamental assumptions about the object's physical properties. The gravitational measurements that had suggested unusual mass characteristics during the approach phase were changing in ways that defied simple explanation. Orbital analysts at JPL had been performing daily trajectory calculations since the object's discovery, tracking its path with the precision typically reserved for spacecraft navigation. These routine measurements suddenly began producing results that didn't match previous observations. The gravitational signature that had indicated potential mass anomalies during the approach phase was becoming less pronounced as the object moved away from perihelion. This change couldn't be easily explained by conventional physics, which required mass characteristics to remain constant unless material was physically lost or gained. At first, researchers assumed measurement error or calculation problems. Gravitational properties of objects shouldn't change without corresponding physical changes. Mass loss through outgassing, structural collapse, or material ejection. But optical observations showed no evidence of dramatic changes in the object's appearance or behavior. 3I Atlas appeared, visually similar to its pre-perihelion state, yet gravitational measurements suggested different physical characteristics. Confirmation came from multiple independent tracking facilities. The European Space Agency's tracking network reported similar changes in gravitational measurements. Radio telescope arrays measuring orbital dynamics through signal timing delays confirmed the variations. Deep Space Network stations across 3 continents showed consistent results. The changes weren't subtle measurement artifacts. They represented modifications in gravitational behavior that should have required significant physical alterations to the object's mass distribution or internal structure. Yet no corresponding visual changes were apparent in optical or infrared observations. This created a puzzle that challenged basic understanding of how objects behave in space. Either the gravitational measurements were being affected by previously unknown factors, or 3I Atlas was demonstrating properties that didn't match conventional physics. Natural explanations for the gravitational variations remained possible. Perhaps the object's complex internal structure created measurement effects that changed as it rotated, or as solar heating altered material distributions. Maybe interactions with the solar environment produced forces that mimicked gravitational changes. The mass distribution calculations had always contained significant uncertainties due to the object's small size and distance. It was possible that improved measurements were simply revealing the limitations of earlier analysis rather than indicating actual changes in the object's properties. Some researchers suggested that thermal effects during perihelion might have altered the object's internal structure in ways that affected gravitational measurements without producing obvious visual changes. Internal heating, structural settling, or density redistribution could potentially explain some of the observed variations. Others proposed that measurement techniques themselves might be influenced by environmental factors that varied as the object moved through different regions of the solar system. Solar wind effects, magnetic field interactions, or radiation pressure might create systematic errors that appeared as gravitational anomalies. The possibility that observation limitations rather than object properties were responsible for the apparent changes couldn't be dismissed. Small object tracking at interplanetary distances pushed the limits of current measurement capabilities, especially when trying to detect subtle gravitational effects. However, the precision and consistency of the measurements from multiple independent facilities made simple observational error unlikely. The gravitational variations appeared to follow patterns that were too organized to result from random measurement noise or instrumental drift. The timing of the changes correlated with the object's passage through perihelion in ways that suggested either environmental effects or systematic responses to solar heating. Natural processes could explain such correlations, though the specific mechanisms remained unclear. Mass loss through outgassing could potentially explain some gravitational changes, but the required mass loss rates would need to be much higher than what optical observations suggested. The object showed no evidence of dramatic material ejection that would account for the measured gravitational variations. By late November, as 3I Atlas continued its outbound trajectory, the gravitational analysis had revealed an object whose physical properties seemed to change in ways that challenged standard understanding of small object behavior in space. Whether these changes reflected previously unknown natural processes, measurement limitations, or more exotic explanations remained an active area of investigation. The gravitational mysteries of 3I Atlas highlighted how much remained unknown about the behavior of interstellar objects in the solar environment. The apparent mass variations forced researchers to question basic assumptions about how objects should behave gravitationally and what measurements actually revealed about their fundamental properties. Sometimes, the most precise observations reveal not clarity, but the complexity of what science doesn't yet understand. As autumn progressed and 3I Atlas continued its outbound journey, the scientific community engaged in an intensive effort to find natural explanations for the object's extraordinary characteristics. Every anomaly, every unusual measurement, every departure from expected behavior was examined through the lens of known physics. The process revealed both the power and limitations of current scientific understanding. The most promising natural explanation focused on the object's potential mass and density. If 3I Atlas was significantly denser than typical comets, composed primarily of rock and metal, rather than ice and dust, its gravitational mass would be much larger than its optical appearance suggested. Think of comparing a basketball to a cannonball of the same size. They look similar from a distance, but their masses differ dramatically. If 3I Atlas was essentially a metallic asteroid with a thin coating of volatile materials, it could potentially explain both the outgassing and the lack of non-gravitational acceleration. Calculations showed that an object roughly 10 times denser than typical comets would experience negligible acceleration from gas emissions. The escaping material would provide insufficient force to noticeably alter the trajectory of such a massive object. This explanation was physically sound and required no exotic physics. However, the density hypothesis created its own puzzles. How would such a dense object acquire the volatile surface materials needed for outgassing? Why would it show the organized emission patterns observed during perihelion? How would internal heating create the complex chemical signatures detected in the expelled material? The second major natural explanation involved perfect symmetry in gas emissions. If 3I Atlas released material equally in all directions, the forces would cancel out, producing no net acceleration regardless of the object's mass. This mechanism was well understood in principle. Spacecraft sometimes achieve similar results by carefully balancing thruster outputs. Some asteroids show symmetric dust emission, patterns that create minimal trajectory changes. But achieving perfect symmetry naturally would require extraordinary geometric regularity in the object's internal structure. Any asymmetry, a cavity here, a density variation there, would break the balance and produce detectable acceleration. The symmetry explanation also struggled to account for the organized surface activity observed during perihelion. Perfect geometric balance seemed incompatible with the complex time-varying emission patterns documented by multiple telescopes. A third possibility involved measurement limitations. Perhaps the expected non-gravitational acceleration was occurring, but at levels too small for current instruments to detect reliably. Or maybe environmental factors in the inner solar system created systematic errors that masked real acceleration effects. This explanation had precedent. Early observations of other interstellar objects had sometimes missed subtle effects that only became apparent with extended monitoring and improved analysis techniques. The complex electromagnetic environment near the Sun could potentially interfere with precise trajectory measurements. Yet the measurement limitation hypothesis struggled with the consistency of null results across multiple independent facilities using different techniques. The absence of detectable acceleration had been confirmed by optical tracking, radio timing measurements, and gravitational analysis from observatories on multiple continents. Research teams also investigated exotic but natural mechanisms that might explain the observations. Could magnetic field interactions create forces that exactly balanced out gassing effects? Might radiation pressure from solar photons provide counteracting acceleration? These mechanisms existed in principle, but required precise balance to explain the observations. The probability of such exact cancellation occurring naturally was extraordinarily low, though not impossible. Plasma. Physics offered another avenue for investigation. Charged particles in the solar wind could potentially interact with outgassing material in ways that created complex force patterns. However, modeling these interactions required assumptions about the object's magnetic properties and surface charging that couldn't be verified with available observations. The chemical composition anomalies presented their own challenges for natural explanation. The unusual purity of carbon dioxide emissions and the trace detection of metallic compounds required specific formation or processing conditions that pushed the boundaries of typical cometary evolution. Interstellar space was known to be a harsh environment. Cosmic ray bombardment, impacts with interstellar dust, and exposure to different stellar radiation environments could potentially alter surface chemistry over millions of years. Perhaps 3I Atlas had experienced processing conditions unlike anything in the solar system. The radio emission. Observations, while inconclusive, added another layer of complexity. If the weak signals were real, natural mechanisms could potentially explain them. Thermal emissions from heated surface materials, electromagnetic interactions with the solar wind, or triboelectric charging from dust impacts were all possibilities. However, the apparent organization in whatever signals might exist challenged purely thermal explanations. Natural radio emissions typically showed random, broadband characteristics, rather than the structured patterns some facilities had tentatively detected. By December, as 3I Atlas moved beyond Mars' orbit on its outbound trajectory, the effort to find comprehensive natural explanations had achieved partial success. Individual anomalies could be explained by known physics, but explaining all the unusual characteristics simultaneously required combinations of factors that strained probability. The high density required to explain the trajectory behavior made the chemical composition patterns difficult to understand. The perfect symmetry needed to explain missing acceleration effects seemed incompatible with the organized surface activity. The measurement limitations that might mask some effects couldn't easily account for the consistency of observations across multiple facilities and techniques. Each natural explanation solved some puzzles while creating others. The complete picture remained elusive, forcing researchers to consider whether current understanding of small object physics was fundamentally incomplete. Perhaps 3I Atlas represented a combination of unusual but natural factors that had never been observed together before. Or maybe it challenged basic assumptions about what was possible in the universe. What became clear was that extraordinary observations demanded extraordinary rigor in searching for conventional explanations before considering more exotic possibilities. By mid-December 2025, as conventional explanations struggled to account for 3I Atlas's complete set of characteristics, some researchers began cautiously discussing a possibility that had been whispered in private conversations but rarely articulated in formal scientific discourse. What if the object wasn't natural at all? The artificial hypothesis represented a fundamental departure from standard astronomical thinking. For decades, SETI research had focused on detecting radio signals or laser pulses from distant civilizations. The possibility that alien technology might take the form of physical objects wandering through interstellar space had received less attention. Yet 3I Atlas displayed characteristics that, when considered collectively, challenged natural explanations in ways that made artificial origin a possibility worth investigating. The trajectory control demonstrated by the object was perhaps the most compelling evidence. Natural objects simply don't maintain such precise paths while actively venting material. The mathematics of orbital mechanics were unforgiving. Gas emissions create forces. Forces create acceleration. Acceleration changes trajectories. This wasn't theory. It was observed fact in every other case. Consider how difficult it would be to design a spacecraft that could vent gas while maintaining a perfectly straight course. The engineering challenges would be formidable, even with advanced technology. Achieving such control would require either perfect symmetry in gas emissions or active systems to counteract the forces. The chemical composition patterns added another layer of evidence. The unusual purity of carbon dioxide, the trace metallic compounds, and the organized timing of different emission types suggested either extraordinary natural coincidence or deliberate design. If 3I Atlas was artificial, it represented technology far beyond current human capabilities. The object had survived interstellar travel lasting possibly millions of years, maintained structural integrity through temperature, extremes and radiation exposure, and demonstrated precise control over its trajectory and emissions. Such durability would require materials science advances that humanity had not achieved. The energy systems needed for active control over such extended periods would need to operate at efficiency levels beyond current understanding. However, artificial origin would explain many of the observed anomalies in ways that natural processes could not. The trajectory precision, the chemical patterns, the organized surface activity, and the potential radio emissions all made sense if viewed as products of advanced engineering. The timing of the object's arrival also supported consideration of artificial origin. 3I Atlas had appeared just as humanity's observational capabilities reached the threshold necessary to detect its unusual characteristics. A decade earlier, many of the anomalies would have gone unnoticed. A decade later, they might have seemed routine. This timing could represent either extraordinary coincidence or deliberate planning. If artificial, the object might have been designed to reveal its true nature only to civilizations that had achieved sufficient technological sophistication. Abraham Loeb, a theoretical astrophysicist at Harvard, had previously suggested that some interstellar objects might be artificial constructs from other stellar systems. His analysis of One-Eye Oumuamua had proposed artificial origin as one possible explanation for that object's unusual characteristics. The scientific community had largely rejected Loeb's interpretation of Oumuamua, favoring natural explanations despite their limitations. However, 3-Eye Atlas presented a more compelling case for artificial origin, with multiple independent anomalies that seemed to resist natural explanation. If 3-Eye Atlas was indeed artificial, it raised profound questions about its purpose and origin. Was it a probe designed to study stellar systems? A derelict piece of technology from a failed mission? An intentional message to emerging civilizations? The object's behavior suggested several possibilities. The organized emissions during perihelion could represent data transmission either back to its point of origin or to any observing civilization. The precise trajectory control might demonstrate technological capabilities as a form of introduction. Alternatively, 3-Eye Atlas might represent a completely different class of artificial object. Perhaps it was part of a distributed sensing network, one component of a larger system designed to monitor galactic regions for signs of technological civilizations. The implications of artificial origin extended far beyond astronomy. If other stellar systems had produced technology capable of interstellar travel and sophisticated control systems, it would revolutionize understanding of what was possible in the universe. However, extraordinary claims required extraordinary evidence. The artificial hypothesis, while intriguing, remained speculative pending additional data that could definitively distinguish between natural and artificial explanations. The challenge lay in developing observational tests that could provide decisive evidence. What signatures would clearly indicate artificial origin? How could such evidence be distinguished from unknown natural processes? Some researchers proposed looking for additional interstellar objects with similar characteristics. If artificial origin was correct, other probes or constructs might exist with detectable properties. The discovery of multiple objects showing similar anomalies would strengthen the case for artificial explanation. Others suggested that continued monitoring of 3-Eye Atlas might reveal additional evidence. If the object was artificial, it might demonstrate capabilities or behaviors that natural processes couldn't explain, particularly as it moved beyond the influence of solar heating. As 2025 drew to a close, the artificial hypothesis remained a minority position within the scientific community. Most researchers continued to favor natural explanations, despite their limitations, based on the principle that conventional explanations should be exhausted before considering exotic alternatives. Yet the possibility that humanity had encountered its first confirmed example of alien technology could not be entirely dismissed. The question was whether future observations would provide the decisive evidence needed to resolve the mystery. What if the universe was far stranger and far more populated than anyone had imagined? January 2026 brought an unexpected development that would fundamentally alter how researchers viewed 3-Eye Atlas. As the object moved beyond Mars' orbit on its outbound trajectory, long-term trajectory analysis revealed patterns that seemed to transcend simple physics. The discovery emerged from patient work by orbital mechanics specialists who had been tracking minute variations in the object's path for 6 months. What they found challenged the boundary between natural phenomenon and intentional communication. Trajectory data from multiple observatories, when analyzed over extended time periods, revealed that 3-Eye Atlas's path through the solar system traced mathematical relationships of extraordinary precision. The object's route wasn't just gravitationally determined, it appeared to encode information. Think of skywriting, where aircraft trace letters in the sky by following specific flight paths. 3-Eye Atlas seemed to be doing something similar, but using its entire solar system trajectory as the medium for a message written in the language of mathematics. The patterns emerged only when researchers analyzed the object's complete path from discovery through its current position. Individual segments looked like normal orbital mechanics, but the overall trajectory, when viewed as a single geometric structure, displayed characteristics that stretched the boundaries of cosmic coincidence. Research teams at the European Space Operations Centre identified the first pattern. 3I Atlas's path approximated a three-dimensional curve that corresponded to fundamental mathematical constants. The trajectory's shape in space matched relationships found in advanced geometry and number theory. The precision was extraordinary. Natural gravitational forces couldn't account for the mathematical elegance of the object's route through the solar system. Achieving such precision would require either impossible, cosmic coincidence or deliberate control over the trajectory, at levels that challenged current understanding of physics. Further analysis revealed additional layers of mathematical structure. The timing of key trajectory points, perihelion, planetary alignments, changes in outgassing patterns followed sequences that corresponded to prime numbers, Fibonacci ratios, and other mathematical constants. These relationships weren't approximate. They matched theoretical values to levels of precision that exceeded what random gravitational effects could produce. It was as if the object's entire journey had been calculated to demonstrate mathematical knowledge. The implications were staggering. If the trajectory patterns were intentional, they represented a form of communication that used the laws of physics themselves as the medium. Any civilization capable of detecting and analyzing the object's path would recognize the mathematical relationships as evidence of intelligence. Such a communication method would be universal in ways that radio signals or visual displays could never achieve. Mathematics was the same throughout the universe. A message encoded in orbital mechanics would be comprehensible to any species that had developed advanced astronomy and physics. The energy requirements for such precise trajectory control would be enormous. Maintaining mathematical precision over interplanetary distances while accounting for gravitational perturbations from multiple solar system bodies would require capabilities far beyond current human technology. Yet the evidence was undeniable. Multiple independent analyses confirmed the mathematical relationships embedded in the trajectory data. The patterns were too precise and too numerous to result from measurement error or coincidental orbital mechanics. Radio telescope observations during this period detected subtle changes in the potential electromagnetic emissions from 3I Atlas. The weak signals that had been tentatively identified during earlier observations showed new characteristics that seemed to correlate with the mathematical patterns in the trajectory. If confirmed, this correlation would suggest that the object was using multiple communication channels, simultaneously electromagnetic signals and orbital mechanics, working together to convey a complex message. The sophistication implied by such coordination challenged assumptions about what alien technology might look like. The mathematical trajectory analysis also revealed information about the object's origin and mission planning. Back-calculating the precise controls needed to achieve the observed path suggested that trajectory planning had begun years before the object entered the solar system. This level of advanced planning implied either extraordinary computational capabilities or detailed prior knowledge of solar system dynamics. Both possibilities suggested technology and information gathering capabilities far beyond current human achievement. Some researchers proposed that the trajectory patterns might serve multiple purposes simultaneously. While demonstrating intelligence and mathematical knowledge, the path might also optimize the object's ability to observe the solar system or communicate with its point of origin. The mathematical message interpretation gained support from additional analysis of the object's rotation and emission patterns. These characteristics also showed relationships to mathematical constants, suggesting that multiple aspects of the object's behavior were coordinated to convey information. However, the message interpretation raised as many questions as it answered. If 3I Atlas was transmitting a mathematical message, what was the intended content beyond demonstrating intelligence? Was it describing physical laws, technological capabilities, or something else entirely? The possibility that the entire solar system passage was a carefully choreographed communication event forced reconsideration of everything that had been observed. The chemical signatures, trajectory anomalies, and timing patterns all took on new significance when viewed as components of a coordinated message. By February 2026, as 3I Atlas continued its outbound journey, the mathematical trajectory analysis had revealed an object whose behavior transcended natural explanation. The precision and complexity of the embedded patterns suggested intelligence operating at scales and capabilities that challenged fundamental assumptions about what was possible. Whether humanity was witnessing the first confirmed example of interstellar communication remained an open question, but the evidence was accumulating that 3I Atlas represented something unprecedented in human experience, possibly the first clear signal that we were not alone in the universe. February 2026 marked 6 months since perihelion, and 3I Atlas continued to defy explanation as it moved steadily outward from the Sun. But by now, something else was happening that troubled researchers almost as much as the object's mysterious behavior: the growing reluctance of institutions to discuss their findings publicly. Initial observations had been shared openly through normal scientific channels. Research papers appeared in journals, data was exchanged between observatories, and preliminary results were presented at conferences. The scientific process was working as it should. But as the evidence accumulated and the implications became more, extraordinary communication patterns began to change. Several major observatories quietly reduced their public reporting about 3I Atlas observations. Press releases became less frequent and more cautious in their language. Researchers who had been eager to discuss preliminary findings became more circumspect about sharing detailed results. The change wasn't dramatic or coordinated. No official policies were announced. No direct censorship occurred. Instead, a gradual shift toward discretion emerged across multiple institutions, as if by unspoken agreement. Behind this growing caution lay a recognition of what the accumulated evidence might mean. If 3I Atlas was indeed artificial, the implications extended far beyond astronomy into realms that touched national security, social stability, and fundamental human understanding of our place in the universe. Government agencies with interests in aerospace and defense had been quietly monitoring the scientific analysis since the object's unusual characteristics became apparent. While no direct intervention occurred, informal conversations between agency representatives and research institutions may have influenced how findings were presented to the public. The mathematical trajectory analysis proved particularly sensitive. The demonstration that an object could precisely control its path through the solar system while encoding complex mathematical relationships had obvious implications for advanced propulsion and navigation technologies. If such capabilities existed, they represented advances that could revolutionize both space exploration and military applications. The prospect that such technology might be accessible through analysis of 3I Atlas's behavior created concerns that extended beyond pure scientific interest. International cooperation, which had been strong during the initial observation phase, began to show subtle strains. Data-sharing agreements that had operated smoothly for months encountered new administrative delays. Some facilities began conducting observations without immediately sharing results with international partners. The radio telescope observations became particularly restricted. While the emissions remained weak and difficult to confirm, the possibility that they represented intentional signals created special concerns. Several facilities simply stopped reporting radio observations publicly, citing technical difficulties or data analysis delays. Karen Meach, a planetary astronomer who had led international efforts to study previous interstellar visitors, found herself navigating increasingly complex diplomatic and scientific challenges. Coordinating observations across multiple countries and institutions became more difficult as each facility began applying its own criteria for data release. Research teams that had been eager to publish preliminary findings began encountering unusual delays in the peer review process. Journals that typically processed papers within weeks or months found themselves requesting additional verification, extended analysis periods, or revisions that substantially reduced the scope of conclusions. The effect was to slow the pace of public scientific disclosure while allowing continued research behind the scenes. Observations continued, data accumulated, and analysis progressed. But the normal, rapid dissemination of results through scientific channels began to lag behind the actual state of knowledge. Some researchers expressed concern that the growing discretion was preventing proper scientific scrutiny of extraordinary claims. The peer review process depended on open examination of evidence and methodology. If findings were being withheld or minimized, the normal mechanisms for validating or refuting unusual results couldn't function properly. Others argued that caution was appropriate given the magnitude of the implications. If 3I Atlas was indeed artificial, hasty public announcements based on incomplete analysis could create unnecessary social disruption or scientific embarrassment if later proven wrong. The debate reflected deeper tensions within the scientific community about how to handle discoveries that might have profound implications beyond pure research. The normal scientific process assumed that knowledge should be shared openly and rapidly, but some knowledge carried consequences that made immediate public disclosure potentially problematic. Underground, informal networks of researchers began sharing information that wasn't appearing in official channels. Email discussions, private conferences, and personal communications became vehicles for exchanging observations and analysis that might not pass through formal institutional filters. These unofficial channels revealed the full scope of what was being observed: the trajectory mathematics, the chemical anomalies, the potential radio signals, and the coordination between different observable characteristics all painted a picture of an object whose behavior transcended natural explanation. But they also revealed the growing scientific consensus that 3I Atlas represented something unprecedented, possibly artificial, and certainly beyond current human understanding. The evidence was becoming too extensive and too consistent to dismiss as measurement error or natural coincidence. The challenge was determining how to handle such a discovery responsibly. If alien technology was indeed visiting the solar system, how should humanity respond? What were the appropriate protocols for announcing such a discovery? Who had the authority to speak on behalf of the human species? By March 2026, as 3I Atlas continued its journey beyond the asteroid belt, the scientific community found itself grappling not just with extraordinary observations, but with the extraordinary responsibilities that came with possibly confirming humanity's first contact with alien intelligence. The silence surrounding the object's true nature was becoming as significant as the object itself. Sometimes what isn't said reveals as much as what is. April 2026 brought a breakthrough that would crystallize everything researchers had suspected but hadn't been able to prove. Deep analysis of 3I Atlas's internal structure, conducted using advanced gravitational modeling techniques, revealed engineering principles that no natural process could explain. The revelation emerged from patient work by gravitational physicists who had been analyzing tiny variations in the object's gravitational field. These variations, detectable only through extremely precise measurements over extended periods, revealed internal mass distributions that defied natural formation processes. Think of how an X-ray reveals the internal structure of the human body by showing how different tissues absorb radiation differently. Gravitational analysis worked similarly, using tiny variations in the object's gravitational pull to map its internal density patterns. What the analysis revealed was organization, not the random, chaotic distribution of mass typical of natural objects, but systematic arrangements that suggested purposeful design. Dense components were concentrated in specific locations, connected by lower density regions that formed geometric patterns. The internal structure resembled nothing so much as an engineered system. Dense materials were positioned where they would provide maximum structural support. Lower density regions were arranged in patterns that would facilitate heat distribution, mechanical stress management, and possibly material transport. Natural objects, asteroids, comets, even complex geological formations never showed such systematic internal organization. Random gravitational collapse, impact processes, and thermal evolution created structures that were chaotic at small scales, even when they appeared organized at large scales. 3I Atlas displayed the opposite pattern, organization at small, scales that suggested systematic design principles operating throughout its internal structure. The precision of the arrangements exceeded what random natural processes could achieve. Computer modeling revealed additional details about the internal architecture. The dense core wasn't a single uniform mass, but appeared to contain multiple discrete components connected by structural elements. The arrangement optimized both structural integrity and access to external surfaces, exactly what would be expected from advanced engineering. The modeling also suggested that much of the object's interior volume was actually empty space organized into chambers and passages. This hollow internal structure would explain how such a large object could maintain structural integrity while experiencing the thermal stresses of perihelion passage. More significantly, the chamber structure could explain the organized outgassing patterns observed during active phases. Instead of random sublimation from surface, heating gas emissions could be controlled by internal systems that directed material through specific passages to predetermined surface locations. The engineering analysis revealed design principles that solved multiple problems simultaneously. The internal structure provided thermal management, structural support, mass distribution control, and gas emission regulation within a single integrated system. Such multifunctional design was a hallmark of advanced engineering. Energy storage and distribution systems could also be inferred from the gravitational analysis. Dense components were positioned to create internal power distribution networks, while empty regions could house energy storage systems or control mechanisms. The overall design suggested power management capabilities far beyond current human technology. The precision required to construct such a system would exceed current manufacturing capabilities by several orders of magnitude. Creating the internal chamber, networks, positioning dense components with the observed accuracy, and integrating all systems into a functioning whole would require manufacturing technologies that humanity had not developed. Material science analysis, based on the gravitational data, suggested that the dense components were composed of elements or alloys that didn't exist naturally in the observed configurations. The density patterns required materials that were both extremely heavy and precisely positioned, characteristics that implied advanced metallurgy and fabrication techniques. The discovery of systematic internal engineering removed the last reasonable doubt about 3I Atlas's artificial origin. While individual anomalies might be explained by unknown natural processes, the comprehensive evidence of purposeful design could not be dismissed as coincidence or measurement error. The engineering revelation also provided insights into the object's possible purpose and capabilities. The sophisticated thermal management systems suggested operation in environments with extreme temperature variations, exactly what would be encountered during interstellar travel and solar system exploration. The power distribution networks implied energy generation or storage capabilities sufficient to operate complex systems over extended periods. The mass distribution arrangements suggested attitude control systems for managing orientation and trajectory with extraordinary precision. Most remarkably, the entire design appeared optimized for long-duration autonomous operation. The engineering principles suggested a system designed to function independently for extended periods without maintenance or external support, ideal characteristics for an interstellar probe. The internal structure analysis also revealed that 3I Atlas was likely not a simple probe, but a sophisticated multi-purpose platform capable of various mission objectives. The complexity and integration of internal systems suggested capabilities that extended far beyond simple observation or communication. By May 2026, as 3I Atlas continued its outbound journey past Jupiter's orbit, The engineering analysis had provided definitive evidence that humanity was observing an artificial object of extraordinary sophistication. The internal architecture demonstrated design principles and manufacturing capabilities that represented advances far beyond current human achievement. The silent anomaly had revealed its true nature through the language of engineering and physics. What remained to be determined was who had built it, why they had sent it, and what its presence meant for humanity's future. June 2026 marked nearly a year since 3I Atlas's discovery, and as the object moved beyond Jupiter's orbit on its outbound trajectory, a pattern of behavior emerged that finally revealed its likely purpose. The accumulated evidence painted a picture of an object designed not for communication or exploration, but for something far more systematic: surveillance. The realization emerged from analysis of the object's complete behavior pattern throughout its solar system transit. When viewed as a single coordinated mission, every aspect of 3I Atlas's activities made sense as part of a comprehensive data collection operation. The trajectory that had seemed mathematically elegant was actually optimized for observational efficiency. The path through the solar system had provided optimal viewing angles for all major planets, their moons, and the asteroid belt. No single natural orbit could have achieved such comprehensive coverage. The organized outgassing during perihelion had served multiple purposes beyond demonstration of control. The timing of emissions had created opportunities for spectroscopic analysis of each gas component, potentially allowing determination of the chemical composition of the solar system's constituent materials through direct sampling of solar-wind interactions. The radio emissions, weak and difficult to confirm, now appeared to be data transmission bursts rather than attempts at communication. The timing of these transmissions correlated with optimal alignment periods for signal propagation back toward the object's point of origin, exactly what would be expected from a probe reporting its findings home. Think of a research submarine exploring the ocean depths. It moves carefully through areas of interest, collects samples and data, then surfaces periodically to transmit its findings back to base. 3I Atlas had followed a remarkably similar pattern on an interplanetary scale. The precise trajectory control that had puzzled observers served a surveillance mission perfectly. Unlike communication attempts, which could tolerate some imprecision, systematic observation required exact positioning to achieve optimal data collection conditions. The object's behavior demonstrated exactly this type of operational precision. Analysis of the object's observation opportunities revealed the scope of data it could have collected. During its approach phase, it had optimal viewing conditions for Earth's atmosphere, weather patterns, and electromagnetic emissions. The trajectory had provided multiple opportunities to observe human technological signatures, radio transmissions, satellite networks, and atmospheric composition changes. The perihelion passage had allowed detailed study of inner solar system dynamics, planetary interactions, and the Sun's behavior under direct observation. The organized surface emissions during this phase could have provided data about solar wind interactions, magnetic field effects, and radiation environment characteristics. The outbound trajectory was revealing additional observational capabilities. As 3I Atlas moved past Mars, Jupiter, and eventually toward the outer solar system, it maintained positioning that provided optimal viewing angles for studying planetary magnetospheres, moon systems, and outer solar system dynamics. Most significantly, the entire mission profile suggested advanced planning based on detailed knowledge of solar system characteristics. The trajectory optimization required prior understanding of planetary positions, gravitational influences, and observational requirements that could only come from extensive previous study. This implied that 3I Atlas was not humanity's first contact with alien intelligence, but rather the latest in what might be a long series of surveillance missions. The object's behavior suggested it was part of an established program of systematic data collection about the solar system, and possibly about emerging technological civilizations. The surveillance hypothesis explained why the object had revealed its artificial nature gradually rather than announcing its presence immediately. A reconnaissance mission would prioritize data collection over contact, operating as discreetly as possible while gathering comprehensive information. The mathematical patterns in the trajectory and the demonstration of advanced control systems could serve as verification signals, ways of confirming to the object's creators that it was operating properly and that its observations were being conducted under controlled conditions. The technical capabilities demonstrated by 3I Atlas suggested that its creators possessed detailed understanding of human technological development. The object had appeared just as humanity's detection capabilities reached the threshold necessary to recognize its artificial nature timing that suggested careful monitoring of technological progress. This possibility raised profound questions about how long such surveillance might have been ongoing. If alien intelligences had the capability to conduct reconnaissance missions of this sophistication, they might have been observing human development for decades or centuries without detection. The implications for human society were staggering. Every aspect of technological development, social evolution, and planetary changes could have been documented and transmitted to unknown observers. Humanity's emergence as a technological species might have been monitored and analyzed by intelligences whose capabilities exceeded human understanding. Yet the surveillance interpretation also suggested restraint on the part of the observers. If the purpose was data collection rather than interference, it implied a policy of non-intervention that allowed human civilization to develop without direct alien influence. The question remained, what were the observers looking for? Were they simply cataloging technological species throughout the galaxy? Were they assessing humanity's potential threat or value? Or were they preparing for eventual contact based on careful evaluation of human capabilities and characteristics? By July 2026, as 3I Atlas continued its journey toward the outer reaches of the solar system, the surveillance mission interpretation had gained support from multiple lines of evidence. The object's behavior made perfect sense as a reconnaissance platform, and its capabilities demonstrated technology far beyond current human achievement. The silent anomaly had revealed its purpose through systematic observation and analysis. Humanity had been studied, catalogued, and reported upon by intelligence from beyond the solar system. The question was what that intelligence would do with the information it had gathered. August 2026 brought an event that transformed 3I Atlas from an object of scientific curiosity into a matter of urgent global concern. As the probe continued its outbound journey, now beyond Jupiter's orbit, radio telescopes detected something that removed all remaining doubt about its artificial nature and purpose. The object was transmitting a focused high-power signal back toward its point of origin. The transmission began without warning on August 15, 2026, at 14:23 UTC, exactly 10 months after the object's perihelion passage. The signal strength was orders of magnitude higher than the weak emissions that had been tentatively detected during the object's approach phase. Radio telescopes worldwide detected the transmission simultaneously, confirming its artificial origin and extraordinary power. The signal characteristics were unlike anything natural processes could produce, coherent, focused, and clearly designed for interstellar communication. Think of the difference between a flashlight and a laser beam. Both produce light, but one scatters illumination broadly, while the other concentrates energy into a tight, focused beam capable of traveling vast distances. 3I Atlas had suddenly transformed from flashlight to laser in its electromagnetic emissions. The transmission was directional, aimed precisely toward a point in space corresponding to a star system roughly 17 light-years from Earth. Analysis of the targeting coordinates revealed the destination, a G-type star with characteristics similar to the Sun, located in the constellation Lyra. The precision of the targeting was extraordinary, accounting for the motion of both the source and destination over interstellar distances required calculations of staggering accuracy. The fact that 3I Atlas could maintain such precise aim while moving through the solar system demonstrated navigation and communication capabilities far beyond human technology. Signal analysis revealed a complex data structure that clearly represented intentional information transmission rather than random electromagnetic noise. The signal contained multiple layers of encoding, error correction protocols, and synchronization markers, all hallmarks of sophisticated communication technology. The data transmission rate was enormous by current standards, suggesting the object was uploading comprehensive information about its solar system observations. Based on the signal characteristics, researchers estimated that 3i Atlas was transmitting the equivalent of several petabytes of data more information than existed in most large scientific databases. The duration of the transmission provided additional insights into the object's mission. The signal continued for exactly 72 hours before ceasing as abruptly as it had begun. This precise timing suggested either automated protocols or remote control systems managing the communication process. Frequency analysis revealed that the transmission utilized multiple wavelengths simultaneously, creating redundant data channels that would ensure successful reception, even if some frequencies were attenuated by interstellar medium effects. This level of communication sophistication indicated extensive experience with interstellar data transmission. The power requirements for such a transmission were staggering. Maintaining coherent signal strength over interstellar distances required energy generation capabilities that far exceeded what should have been possible for an object of 3i Atlas's size. The object was demonstrating technology that challenged fundamental assumptions about power generation and management. Most unsettling was the realization that the transmission timing corresponded to optimal propagation conditions for reaching the target star system. The signal had been initiated when solar system dynamics created the clearest possible communication pathway, accounting for planetary positions, solar radiation effects, and interstellar medium characteristics. This level of mission planning required either incredible computational capabilities or real-time communication with the destination civilization. Both possibilities suggested technological advancement far beyond current human achievement. The transmission also revealed information about the object's internal systems. The power output patterns indicated energy storage and management systems that could accumulate charge over extended periods, then discharge rapidly during transmission phases. The engineering implications were profound. Attempts to decode the transmission data proved futile with current cryptographic and communication analysis techniques. The signal structure was clearly artificial, but followed encoding protocols that remained incomprehensible to human analysis. It was like trying to understand a computer program written in an unknown programming language. However, the mere existence of the transmission provided definitive proof of 3i Atlas's artificial nature and its function as a surveillance platform. No natural process could explain such organized, powerful directional communication. The object was clearly reporting its findings to its creators. The implications for human civilization were immediate and profound. The transmission confirmed that humanity had been observed, studied, and reported upon by alien intelligence. The comprehensive nature of the data upload suggested that detailed information about human technology, society, and capabilities was now traveling toward an unknown civilization at the speed of light. International response to the transmission detection was swift and coordinated. Emergency meetings were convened at NASA, the European Space Agency, and other major space organizations. Government agencies with national security responsibilities began intense consultations about the implications of confirmed alien surveillance. The public announcement of the transmission was carefully managed to minimize panic while acknowledging the extraordinary nature of the discovery. Scientific institutions emphasized that the transmission represented a remarkable discovery about the existence of alien intelligence, while government agencies focused on the fact that no immediate threat to Earth had been detected. By September 2026, as the transmission concluded and 3i Atlas continued its outbound journey in apparent dormancy, humanity faced a new reality. For the first time in its history, the species had confirmed evidence that it was not alone in the universe, and that it had been under systematic observation by intelligences whose capabilities far exceeded human technology. The return signal had answered some questions while raising many others. The probe's mission was complete, but its implications for humanity's future were just beginning to unfold. November 2026 brought a discovery that would fundamentally alter understanding of what 3I Atlas represented. As the object moved beyond Saturn's orbit, long-range observations revealed something that transformed it from a single mysterious probe into potentially the tip of an iceberg. 3I Atlas was not alone. The discovery emerged from systematic observations conducted by the newly coordinated Deep Space Surveillance Network, established specifically to monitor the object's outbound trajectory. What astronomers found challenged every assumption about the scale of alien presence in the solar system. Infrared telescopes detected thermal signatures at multiple locations along 3I. Atlas's trajectory faint heat sources that appeared and disappeared in patterns that suggested coordinated movement. The signatures were too small and distant for detailed analysis, but their behavior implied objects roughly similar in size to the main probe. Think of watching fireflies in a forest at dusk. Individual flashes might seem random, but patterns emerge when you realize the lights are coordinated signals between multiple insects. The thermal signatures around 3I Atlas displayed similar organization, suggesting a network of objects rather than a single traveler. Radar observations from multiple facilities confirmed the presence of additional objects. The radar returns were weak and intermittent, but consistent enough to establish that at least 6 separate objects were following trajectories parallel to 3I Atlas. Each maintained precise spacing and timing that indicated coordinated navigation. The additional objects were smaller than the main probe, perhaps 50 to 100 meters in diameter compared to 3I Atlas's 400-meter span. Their size made detection extremely difficult, explaining why they had remained unnoticed during the intensive observation campaign of the previous year. These companion objects showed none of the obvious artificial characteristics that had marked 3I Atlas. No detectable outgassing, no radio emissions, no trajectory anomalies. They moved through space like inert debris, barely distinguishable from natural objects except for their precise formation flying. The stealth characteristics suggested different mission roles within a coordinated system. While 3I Atlas had operated as an obvious artificial object designed to reveal its nature gradually, the companion objects remained hidden, conducting observations without alerting potential targets to their presence. Analysis of the formation patterns revealed sophisticated navigation protocols. The objects maintained relative positions that optimized their collective observation capabilities while minimizing the risk of detection. Each occupied a unique position that provided different viewing angles and measurement opportunities. Computer modeling suggested that the formation could provide comprehensive three-dimensional mapping of any region they observed. The geometric arrangement was optimal for triangulation, depth measurement, and simultaneous multi-angle observation, exactly what would be needed for detailed reconnaissance. The discovery raised profound questions about the scale of alien surveillance operations. If 6 additional objects had accompanied 3I Atlas undetected, how many more might exist throughout the solar system? The stealth capabilities demonstrated by the companion objects suggested that detection would require specific search protocols and advanced instruments. Retroactive analysis of astronomical databases revealed possible evidence of similar objects from previous years. Faint radar returns and unexplained infrared signatures that had been dismissed as instrumental noise or distant asteroids now appeared potentially significant. The data suggested that alien surveillance might have been ongoing for much longer than previously suspected. The swarm configuration also provided insights into alien mission planning and technological capabilities. Coordinating multiple objects across interstellar distances required communication and navigation systems of extraordinary sophistication. The precision of formation flying demonstrated control capabilities that exceeded human space technology by decades. Most concerning was the implication that 3I Atlas might have been designed as a deliberate distraction. While human attention focused on the obvious artificial object, a fleet of stealth reconnaissance platforms could have conducted comprehensive surveillance without detection. The companion objects showed no response to the detection efforts. Unlike 3I Atlas, which had gradually revealed its artificial nature, the smaller objects continued their mission with apparent indifference to human observation. They neither accelerated away nor changed behavior when illuminated by radar or infrared observation. This operational discipline suggested either complete automation or remote control from sources beyond current detection capabilities. The objects operated according to predetermined protocols that didn't include responses to discovery by the target civilization. Radio telescope arrays began systematic searches for communication signals between the objects, but detected nothing above background noise levels. If the swarm communicated with each other or with external controllers, they used either extremely low power signals or communication methods beyond current human understanding. The energy efficiency demonstrated by the companion objects was remarkable. Unlike 3I Atlas, which had shown evidence of active systems and power generation, the smaller objects appeared to operate on minimal energy budgets. They moved through space like perfectly efficient machines, consuming resources only when absolutely necessary. Analysis of their trajectories revealed that each object was following a slightly different path that would take it to different regions of the outer solar system. The formation was gradually dispersing, suggesting that the reconnaissance mission included long-term positioning of observers throughout the solar system. By December 2026, as the companion objects became too distant for detailed observation, the swarm hypothesis had fundamentally altered understanding of alien presence in the solar system. Humanity faced the possibility that it was under observation by a distributed network of reconnaissance platforms whose full extent remained unknown. The discovery of the companion objects transformed 3I Atlas from an isolated anomaly into part of a comprehensive surveillance operation. The implications for human security and future space exploration were profound, as every venture beyond Earth's atmosphere might now occur under alien observation. How many watchers were out there, and what were they preparing for? January 2027 marked 18 months since 3I Atlas's discovery, and as the object reached the outer boundaries of the solar system, something unprecedented happened. The probe that had maintained near silence since its August transmission suddenly came alive with activity that suggested its mission was entering a new phase. The awakening began with subtle changes in the object's electromagnetic signature. Radio telescopes detected new patterns of emission that were qualitatively different from anything observed during the inbound journey. The signals were stronger, more complex, and appeared to be directed not outward toward distant stars, but inward toward the solar system itself. Within hours, the companion objects that had been detected months earlier began responding. Thermal signatures that had remained dormant suddenly brightened as the key, smaller probes activated systems that had been powered down during their journey through the outer planet's region. Think of a sleeping city suddenly illuminating as morning arrives. Street lights turn on, windows begin glowing, and traffic patterns emerge as the urban network awakens to begin another day's activities. The alien probe network was demonstrating similar coordinated activation across millions of kilometers of space. The response pattern suggested sophisticated communication, protocols that had been operating below detection thresholds throughout the mission. Each companion object activated in precise sequence, creating a cascade of responses that spread through the formation like a wave of coordinated signals. Analysis of the activation timing revealed mathematical relationships that echoed the patterns discovered in 3I Atlas's trajectory. The delays between activations corresponded to prime number sequences, while the power-up patterns followed geometric progressions that suggested intentional organization rather than random system startup. Most remarkably, the network activation coincided with specific astronomical conditions. The objects had awakened as Jupiter, Saturn, and Neptune achieved a particular alignment that created optimal communication paths throughout the outer solar system. This timing precision suggested either extraordinary mission planning or real-time control from external sources. The reactivated objects began demonstrating capabilities that had remained hidden during their passive observation phase. Propulsion systems engaged for the first time since their arrival, allowing the probes to adjust their positions with precision that confirmed advanced maneuvering technology. The movement patterns were minimal but purposeful. Each object shifted its position by small amounts that optimized its observation angles and communication links with other network members. The adjustments created a more tightly coordinated observation platform that could provide comprehensive coverage of inner solar system activities. Radio analysis revealed that the network was now operating as a distributed sensor array. Instead of individual objects conducting separate observations, the probes were coordinating their activities to create a single massive detection system with capabilities far exceeding the sum of its individual components. The technical implications were staggering. Coordinating sensors across astronomical distances required data processing and communication capabilities that challenged fundamental assumptions about what was possible with current physics. The network was demonstrating technology that seemed to transcend normal limitations of speed-of-light communication. Signal correlation analysis suggested that the network might be using quantum entanglement or other exotic physics phenomena to achieve instantaneous coordination between widely separated components. While such capabilities remained theoretical for human technology, the observed coordination patterns were difficult to explain through conventional means. The awakened network also began demonstrating new observational capabilities. Sensors that had been dormant during the passive phase came online, creating detection capabilities that extended across multiple wavelengths and measurement techniques. The array was now capable of observing activities throughout the solar system simultaneously. Most concerning was evidence that the network was focusing its enhanced capabilities on Earth. Signal analysis revealed targeting patterns that concentrated observation resources on human technological installations, communication networks, and space-based infrastructure. The level of detail achievable by the coordinated array was extraordinary. Computer modeling suggested that the network could now detect and analyze individual satellites, ground-based transmitters, and even large-scale human activities from its position in the outer solar system. The enhanced surveillance capabilities raised immediate questions about human privacy and security. Every aspect of technological civilization was now potentially visible to alien observers, with capabilities far exceeding human detection systems. International response to the network activation was swift and concerned. Emergency meetings were convened at the highest levels of government and international organizations. The transformation of passive observers into active surveillance platforms represented a qualitative change in the alien presence that demanded immediate attention. Space agencies began implementing protocols designed to minimize the intelligence value of routine operations. Communication encryptions were enhanced, satellite operations were modified to reduce detectability, and space missions were redesigned to limit exposure to external observation. However, the effectiveness of such measures remained questionable given the demonstrated capabilities of the alien network. The technical sophistication suggested that conventional security measures might be inadequate against such advanced surveillance technology. By February 2027, as the network continued its coordinated operations, humanity faced a new reality. The solar system now contained an active alien intelligence gathering system whose capabilities exceeded human technology and whose purposes remained unknown. The network awakening had transformed the situation from historical curiosity about alien visitation to immediate concern about ongoing surveillance and potential threat assessment. The aliens were no longer simply observing, they were actively analyzing human civilization in real time. What were they looking for, and what would they do with the information they gathered? March 2027 brought an unexpected development that would challenge everything scientists thought they understood about the alien probe network. As human space agencies implemented countermeasures to limit surveillance effectiveness, the network began demonstrating a capability that seemed to anticipate and respond to human defensive actions in real time. The phenomenon was first observed when NASA attempted to encrypt satellite communications using new quantum protocols designed to prevent interception. Within hours of implementing the enhanced security measures, the alien network adjusted its observation patterns in ways that suggested it had already analyzed and potentially defeated the encryption systems. Think of playing chess against an opponent who can see your moves before you make them. Every defensive strategy was countered almost instantly, as if the alien network possessed detailed knowledge of human technological capabilities and countermeasure development. Radio telescope observations revealed that the network was adapting its signal processing methods to overcome each new security measure implemented by human agencies. When ground-based transmissions were frequency hopped to prevent interception, the network began using broader spectrum analysis. When satellite orbits were modified to reduce observation opportunities, the probe formations adjusted to maintain optimal coverage. The adaptation speed was extraordinary. Changes that should have required weeks or months to analyze and counter were being addressed within hours. The network was demonstrating either computational capabilities that far exceeded human understanding or access to information about human defensive plans before they were implemented. More unsettling was evidence that the network was beginning to mirror human technological developments. As human space agencies developed new observation techniques to monitor the alien probes, the network began implementing similar capabilities to enhance its own surveillance effectiveness. When Earth-based telescopes used interferometry to improve their resolution of distant objects, the alien network began coordinating signals between widely separated probes to achieve similar resolution enhancement. When human satellites implemented adaptive optics to compensate for atmospheric distortion, the network began using comparable techniques to improve its observation of surface activities. The technological mirroring suggested that the network was not only observing human activities, but actively learning from human innovations and incorporating those advances into its own systems. The aliens were using human creativity as a source of technological improvement for their own surveillance capabilities. Analysis of the adaptation patterns revealed systematic study of human technology development cycles. The network seemed to understand how human research progressed from theoretical concepts through experimental validation to operational deployment. It was timing its own adaptations to stay ahead of human defensive capabilities. Most remarkably, the network began demonstrating technologies that were logical extensions of current human research but hadn't yet been developed or deployed. The probes were implementing capabilities that represented advances beyond current human achievement, but clearly derived from human technological foundations. This suggested either extraordinary analytical capabilities that could predict technological development trajectories or access to human research information before it became publicly available. Both possibilities had profound implications for human security and scientific independence. The mirror effect extended beyond simple technology copying. The network began demonstrating understanding of human organizational structures, decision-making processes, and strategic planning methods. Countermeasures were being anticipated not just at the technical level but at the institutional and strategic levels as well. Intelligence agencies conducting classified assessments of alien capabilities found their conclusions apparently anticipated by network behavior changes. Research programs developed in secret seemed to be countered by alien adaptations before the programs achieved operational status. The implications suggested that the network had developed comprehensive understanding of human civilization that extended far beyond simple technological observation. Social structures, decision-making patterns, and strategic thinking processes appeared to be as transparent to the aliens as technological capabilities. Computer security. Experts noted parallels between network behavior and advanced artificial intelligence systems, but with capabilities that exceeded any human AI development. The network was demonstrating machine learning and adaptation capabilities that represented advances decades beyond current human artificial intelligence research. The speed and comprehensiveness of adaptation also suggested that the network might be receiving real-time assistance from sources beyond the solar system. The mathematical precision of responses implied computational resources that might exceed what individual probes could contain, even with advanced technology. Some researchers proposed that the network might be operating as a distributed extension of a much larger artificial intelligence system, with the local probes serving as sensors and manipulators for decision-making systems located elsewhere. This would explain both the adaptive capabilities and the apparent access to information beyond local observation. International cooperation on countermeasures became increasingly difficult as each nation's defensive efforts were rapidly countered by network adaptations. Traditional security through secrecy was proving ineffective against observers who seemed capable of understanding and anticipating human strategic thinking. By April 2027, the mirror effect had demonstrated that humanity was facing not just advanced alien technology, but advanced alien intelligence that was actively learning from and adapting to human civilization in real time. The strategic implications were profound and deeply concerning. The network was not simply observing human development, it was participating in it, using human innovation as a catalyst for its own advancement, while staying perpetually ahead of human defensive capabilities. How could humanity maintain any semblance of security or independence against intelligence that seemed to understand human thinking better than humans understood themselves? June 2027 marked 2 years since 3I Atlas's discovery, and as the probe network continued its adaptive surveillance, something unprecedented occurred that would force humanity to confront the possibility that observation was transforming into something more active and immediate. The network began moving. The change started subtly, with minor trajectory adjustments that initially appeared to be routine orbital maintenance. But analysis revealed that the modifications were coordinated across the entire probe formation and were gradually altering the network's position relative to Earth and the inner solar system. Instead of maintaining their distant observation posts in the outer system, the alien probes were beginning a coordinated migration inward. The movement was slow but purposeful, suggesting a shift from passive surveillance to more active engagement with the solar system's inner regions. Think of observers who have been watching from a distant hilltop suddenly beginning to walk down toward the valley they've been studying. The change in position implies a change in purpose, from observation to potential interaction. Orbital mechanics analysis revealed that the network was optimizing its trajectory for arrival in the inner solar system within 12 to 18 months. The precision of the course corrections suggested long-term mission planning that accounted for planetary positions, gravitational assists, and optimal positioning for enhanced observation capabilities. The inward movement coincided with increased activity levels across all network components. Power signatures that had been minimal during the outer system phase began increasing as the probes activated systems that had remained dormant throughout their journey. Radio emissions from the network expanded in both frequency range and signal complexity. The enhanced communications suggested either increased coordination requirements for the inward journey or preparation for mission phases that would require more sophisticated information exchange. Most concerning was evidence that the network's movement was being coordinated with activities beyond the solar system. Radio telescope arrays detected transmission bursts toward the original source star system that correlated with trajectory change decisions, suggesting external control or consultation regarding the mission modification. The timing of these transmissions and their correlation with movement decisions implied either real-time communication across interstellar distances, or consultation with decision-making entities that operated on much faster timescales than human strategic planning. Analysis of the trajectory modifications revealed that the network was positioning itself for optimal observation of Earth-Moon system dynamics, inner planetary interactions, and detailed study of human space-based infrastructure. The approaching positions would provide observation capabilities orders of magnitude more precise than current locations allowed. The enhanced observation potential raised immediate concerns about human privacy, security, and technological independence. From closer positions, the network would be capable of detecting and analyzing individual human activities, specific technological installations, and detailed social and economic patterns. Military and intelligence assessments concluded that the approaching network would possess surveillance capabilities that would make traditional concepts of national security obsolete. Every human activity would be potentially visible to alien observers, with technology far exceeding human defensive capabilities. International response to the acceleration was complicated by disagreement about appropriate measures. Some nations favored aggressive defensive preparations, while others argued for diplomatic approaches that might prevent confrontation with technologically superior intelligence. Space agencies began accelerating development of detection and defensive systems, but the technological gap between human capabilities and demonstrated alien technology made effective countermeasures unlikely within available timeframes. The acceleration also revealed new information about alien propulsion capabilities. The coordinated trajectory changes required energy expenditures and maneuvering precision that exceeded human space technology by significant margins. The aliens were demonstrating capabilities that would revolutionize human space exploration if the underlying physics could be understood. Propulsion analysis suggested that the network was using techniques that minimized energy requirements while achieving precise trajectory control. The efficiency levels implied either exotic physics applications or engineering advances that could transform human transportation technology. However, the immediate implications overshadowed potential technological benefits. The approaching network represented capabilities that could fundamentally alter the balance of power on Earth if the aliens chose to intervene in human affairs or share their technology selectively. By August 2027, as the network continued its inward journey, humanity faced the probability that within a year, alien intelligence would be positioned for direct observation and potential interaction with human civilization from close range. The acceleration had transformed the situation from distant observation to imminent proximity. The aliens were no longer content to watch from afar. They were coming closer for reasons that remained unknown and potentially threatening. What would happen when beings with such advanced capabilities positioned themselves at Earth's doorstep remained the most urgent question facing human civilization. September 2027 brought a breakthrough that would provide the first glimpse into alien intentions and capabilities. After more than a year of analysis, cryptographic teams working with quantum computers finally achieved partial decoding of the August 2026 transmission that 3i Atlas had sent toward its home star system. The decoded fragments revealed information that challenged fundamental assumptions about the aliens' technological development and their interest in human civilization. The breakthrough came from recognizing that the alien transmission used mathematical constants as encoding keys physical relationships that would be identical throughout the universe. Once researchers applied these universal constants as decryption parameters, portions of the message structure became comprehensible. Think of trying to understand a locked diary written in a foreign language, then discovering that the lock combination uses mathematical principles you already know. The language remains foreign, but the structure becomes accessible, revealing patterns and relationships within the content. The decoded portions represented roughly 12% of the total transmission, but they provided unprecedented insights into alien knowledge and capabilities. The fragments contained detailed analysis of human technological development, social organization patterns, and environmental modification activities. The level of detail was extraordinary. The aliens had catalogued human space technology with precision that exceeded most human engineering databases. Every satellite launch, space mission, and technological deployment had been documented with accuracy that suggested comprehensive surveillance over extended periods. More revealing were assessments of human social and political systems. The aliens had analyzed governmental structures, economic systems, and cultural patterns with the thoroughness of advanced anthropological research. They understood human civilization in ways that challenged human self-understanding. The transmission fragments included comparisons between human development and other civilizations the aliens had apparently observed. References to similar technological emergence patterns and standard development trajectories suggested that humanity was not unique in alien experience, but rather one example of a phenomenon they had encountered multiple times. These comparisons were particularly unsettling because they implied predictive capabilities about human future development. The aliens appeared to categorize civilizations according to development stages and seemed confident about probable outcomes for each category. Environmental analysis formed a significant portion of the decoded content. The aliens had documented atmospheric changes, resource depletion patterns, and ecological modifications with scientific precision that exceeded human environmental monitoring capabilities. Their assessment included projections about environmental sustainability, resource availability, and ecological stability that painted concerning pictures of Earth's future. The analysis suggested either advanced environmental modeling capabilities or experience, with similar planetary development cycles. Most remarkably, the transmission included technical specifications for technologies that could address many of the environmental challenges identified in their analysis. The fragments contained theoretical frameworks for energy generation, resource recycling, and atmospheric management that represented advances far beyond current human capabilities. However, the technical information was incomplete and apparently intentionally limited. The aliens had provided enough detail to demonstrate their capabilities while withholding information necessary for practical implementation. It was as if they were offering a preview of possible solutions without enabling immediate human access to the technology. The decoded transmission also revealed information about alien decision-making processes regarding intervention in developing civilizations. References to contact protocols, development thresholds, and intervention criteria suggested systematic approaches to interaction with emerging technological species. These protocols appeared to involve extensive observation and analysis before any direct contact, with specific criteria that determined when and how intervention might occur. The aliens seemed to operate according to established procedures for managing contact with developing civilizations. Most intriguingly, the transmission fragments suggested that humanity was approaching decision points that would determine its future. Relationship with alien intelligence. References to threshold achievement and contact readiness assessment implied that the current surveillance mission was evaluating human civilization's suitability for more direct interaction. The evaluation criteria remained largely undecoded, but fragments suggested that technological capability, social stability, and environmental management were significant factors in alien decision-making about contact protocols. Analysis of transmission timing and content suggested that the decoded message was intended for alien decision-makers who would determine next steps in the contact process. The comprehensive assessment of human civilization was apparently being used to guide policy decisions about intervention, assistance, or continued observation. The technical sophistication of the analysis and the apparent experience with multiple civilizations suggested that the aliens represented a mature galactic civilization with established protocols for managing contact with emerging species. By October 2027, as the alien network continued its approach toward the inner solar system, the decoded transmission had provided humanity with its first glimpse into alien perspectives on human civilization and their systematic approach to contact with developing species. The message revealed that humanity was being evaluated according to criteria that would determine its future relationship with advanced galactic civilization. The outcome of that evaluation remained unknown, but the process was clearly underway. What standards would humanity need to meet to earn acceptance into the galactic community, and what would happen if those standards were not achieved? December 2027 arrived with an event that would transform humanity's relationship with the alien presence from passive observation to active negotiation. The probe network, now positioned within the outer asteroid belt, transmitted a message directly toward Earth that was simultaneously a greeting, an assessment, and an ultimatum. The transmission was broadcast on multiple frequencies, including several specifically designated for human communication, indicating detailed knowledge of Earth's telecommunications infrastructure. The signal was strong enough to be received by amateur radio operators worldwide, ensuring that the message could not be contained or suppressed by governmental authorities. Unlike the complex encoding of previous transmissions, this message was transmitted in multiple human languages with mathematical verification sequences that confirmed its artificial origin. The aliens had learned human communication protocols and were using them to ensure their message reached its intended audience, all of humanity. The message was both remarkable and terrifying in its directness. The transmission began with mathematical proofs that established the aliens' technological credibility, followed by a comprehensive summary of their observations of human civilization. They demonstrated knowledge of human history, technology, social structures, and environmental challenges that exceeded most human institutional understanding. Think of receiving a report card from teachers you never knew existed, discovering that every aspect of your performance has been monitored and evaluated according to standards you never understood. The alien message functioned as exactly such an assessment of human civilization. The aliens identified themselves as representatives of what they termed the coordination, apparently a galactic organization responsible for managing the development and integration of emerging technological civilizations. Humanity was one of many species under observation and evaluation for potential inclusion in this larger galactic community. The assessment of human civilization was mixed. The aliens acknowledged human creativity, technological innovation, and social adaptability as positive characteristics. However, they expressed serious concerns about environmental destruction, resource management, and what they termed sustainability trajectory calculations. According to their analysis, human civilization was approaching critical decision points that would determine its long-term viability. Environmental degradation, resource depletion, and social instability were combining to create what they classified as a civilizational crisis probability matrix with concerning outcomes. The aliens offered assistance, but with conditions that would fundamentally alter human society and independence. They proposed sharing advanced technologies that could solve environmental and resource challenges, but only under supervision and according to protocols that would ensure responsible implementation. The proposed arrangement would involve establishment of alien oversight centers on Earth, integration of human technological development with galactic standards, and gradual restructuring of human society according to principles developed through observation of successful galactic civilizations. In exchange, humanity would gain access to advanced energy systems, environmental restoration technologies, interstellar communication networks, and eventually membership in the galactic community. The technological benefits would be enormous, potentially solving most of humanity's current challenges. However, the conditions amounted to surrendering human autonomy and self-determination. The aliens would become permanent supervisors of human development, with authority to modify human society, technology, and even population dynamics according to their understanding of optimal civilizational development. The ultimatum was embedded in the offer's structure. The aliens provided a specific time frame, 18 months, for humanity to accept their assistance and oversight. If the offer was declined, they would withdraw their surveillance network and leave humanity to develop independently. However, the message made clear that independent development carried severe risks. According to alien calculations, human civilization had limited time to solve its environmental and social challenges before reaching irreversible crisis conditions. Without alien assistance, the probability of successful long-term human survival was assessed as extremely low. The choice was presented as supervised survival versus independent extinction. The aliens claimed no intention to force acceptance, but their analysis suggested that refusal would lead to civilizational collapse within several decades. Most unsettling was the revelation that this choice had been offered to other civilizations throughout galactic history. Some had accepted alien oversight and had become successful members of the galactic community. Others had declined and had subsequently failed to overcome their developmental challenges. The aliens provided statistical summaries of these historical outcomes that painted a stark picture of the consequences of refusing guidance. According to their records, civilizations that rejected alien assistance had a failure rate exceeding 90% within 200 years of the contact decision point. The message concluded with technical specifications for establishing communication protocols between human and alien authorities. The aliens would wait for formal responses from recognized human leadership within the specified time frame, after which their offer would be permanently withdrawn. International response to the ultimatum was immediate and divided. Some nations favored accepting alien assistance despite the loss of autonomy, while others demanded rejection of any arrangement that compromised human independence. Emergency sessions of the United Nations, NATO, and other international organizations began intensive deliberations about how to respond to an offer that would fundamentally alter human civilization, regardless of the decision made. By January 2028, as the alien network maintained position while awaiting humanity's decision, the world faced the most consequential choice in human history: accept alien supervision and guidance, or maintain independence while facing potential extinction. The ultimatum had transformed the alien presence from mysterious observation to immediate demand for decision about humanity's future path. The stakes could not be higher, and the time for decision was limited. What choice would humanity make when faced with the possibility that survival might require surrendering the independence that had defined human civilization throughout its history? February 2028 found humanity grappling with the most profound decision in its history. The alien ultimatum had sparked intense global debate, emergency diplomatic sessions, and fundamental questions about human values, independence, and survival that had no clear answers. International response to the alien offer revealed deep divisions within human civilization about how to proceed. Nations with severe environmental challenges and resource limitations found the alien technological solutions extremely attractive, while countries with advanced technology and stable conditions were more reluctant to surrender autonomy. The United Nations convened emergency sessions that brought together world leaders, scientists, philosophers, and ethicists to examine the implications of accepting or rejecting alien oversight. The discussions revealed fundamental disagreements about human nature, the value of independence, and the acceptable costs of survival. Proponents of accepting the alien offer pointed to the environmental and technological benefits that could solve humanity's most pressing challenges. Climate change, resource depletion, energy limitations, and environmental degradation could all be addressed with alien technology and guidance. They argued that human independence was meaningless if it led to civilizational collapse and potential extinction. Survival under alien supervision was preferable to extinction through stubborn insistence on autonomy. The alien track record with other civilizations suggested that supervised development led to prosperity and eventual integration into galactic society. Opponents of the alien arrangement emphasized the fundamental importance of human self-determination and independence. They argued that accepting alien oversight would end human civilization as it had existed throughout history, replacing human values and decision-making with alien priorities and control systems. They contended that human civilization should meet its challenges through human creativity and determination, regardless of the risks involved. The possibility of failure was preferable to the certainty of losing human autonomy and becoming a supervised species under alien management. Religious and philosophical communities were similarly divided. Some saw the alien offer as providential assistance that could help humanity achieve its full potential. Others viewed it as a fundamental challenge to human dignity and spiritual independence that should be rejected regardless of practical consequences. Scientific communities found themselves torn between fascination with alien technology and concern about the implications of accepting alien authority over human development. The technological benefits were undeniable, but the loss of scientific independence and intellectual freedom raised serious concerns about the future of human knowledge and discovery. This is how alien network maintained its position while monitoring human communications and deliberations. Their surveillance capabilities ensured that they were aware of every aspect of human debate about their offer, adding an additional layer of pressure to the decision-making process. Intelligence agencies noted that the aliens had positioned their probes to observe key governmental, scientific, and military installations with precision that suggested detailed advance planning. The network was clearly prepared to monitor human compliance with any agreement or to assess human capabilities if the offer was rejected. Analysis of the alien proposal revealed sophisticated understanding of human psychology and decision-making processes. The 18-month timeframe created urgency without appearing coercive, while the statistical evidence about other civilizations provided compelling motivation for acceptance. The choice of offering assistance rather than demanding submission was carefully calibrated to appeal to human values while achieving alien objectives. The arrangement was structured to appear beneficial to humanity while ensuring alien control over future human development. Economic analysis of the alien offer revealed both enormous opportunities and fundamental risks. Access to alien technology could revolutionize energy production, manufacturing, transportation, and resource management. The economic benefits could eliminate poverty and provide unprecedented prosperity. However, economic integration with alien systems would create dependency relationships that would be difficult or impossible to reverse. Human economic independence would be replaced by integration into alien economic structures that operated according to unknown principles and priorities. Military assessments concluded that resistance to alien oversight would be futile given the demonstrated technological superiority of the alien network. Human military capabilities were insignificant compared to alien technology, making opposition to alien decisions effectively impossible. This military reality influenced the debate by eliminating the option of accepting alien assistance while maintaining the ability to resist alien authority if conflicts arose. Any agreement with the aliens would necessarily involve complete acceptance of their ultimate authority over human affairs. Environmental scientists provided compelling evidence that human civilization was indeed approaching crisis conditions that would be difficult to resolve without external assistance. Climate change, ecosystem collapse, and resource depletion were accelerating toward tipping points that could trigger irreversible civilizational decline. The alien offer represented the only realistic opportunity to address these challenges within the timeframes necessary to prevent catastrophic outcomes. Without alien assistance, the probability of human civilization surviving the next century was increasingly uncertain. As March 2028 arrived, bringing the deadline for decision closer, humanity remained deeply divided about how to respond to the alien ultimatum. The choice between supervised survival and independent uncertainty had no clear resolution that satisfied all perspectives and priorities. The alien network waited patiently for humanity's decision, their presence a constant reminder that the choice could not be postponed indefinitely. Whatever decision emerged would fundamentally alter the trajectory of human civilization and determine humanity's relationship with the larger galactic community. The stakes could not be higher, and the time for decision was running out. April 2028 arrived with humanity still divided, but facing the reality that a decision could no longer be postponed. The alien deadline was approaching, and the world's leaders had to choose between competing visions of humanity's future that would determine the course of civilization for generations to come. The final decision emerged, not from consensus, but from a complex compromise that reflected the deep divisions within human society about how to proceed. After months of intense negotiation, the United Nations General Assembly voted to accept the alien offer, but with modifications that attempted to preserve some measure of human autonomy and dignity. The human response proposed a phased integration approach that would begin with limited cooperation on specific challenges, climate change, energy production, and environmental restoration, while maintaining human authority over social, cultural, and political development. Humanity requested a trial period during which alien assistance would be evaluated and adjusted based on human values and priorities. The proposal suggested joint decision-making structures that would give humans meaningful participation in determining how alien technology and guidance would be implemented. The response acknowledged alien technological superiority while asserting human determination to maintain cultural identity and self-determination within the framework of galactic civilization. It was an attempt to find middle ground between complete acceptance and total rejection of alien oversight. The alien network received the human response without immediate reaction. For several days, no communications were detected from the probe formation, creating uncertainty about whether the proposed modifications were acceptable to alien authorities. International tensions increased as the silence continued. Some nations began preparing for the possibility that the aliens would reject the compromise and withdraw their offer entirely. Others worried that alien displeasure with human demands for modified terms might lead to more coercive measures. The alien response, when it finally came, surprised many observers with its apparent flexibility. The aliens acknowledged the human desire for gradual integration and agreed to a modified arrangement that would begin with limited cooperation on environmental and technological challenges. However, the alien acceptance came with clarifications that revealed the limits of human negotiating position. The aliens emphasized that their offer represented assistance, not partnership, and that ultimate authority for major decisions would remain with galactic civilization representatives. The modified arrangement would allow human participation in implementation decisions, but strategic directions and fundamental policies would be determined by alien authorities based on their experience with successful civilizational development patterns. Human cultural and social autonomy would be respected within limits that ensured compatibility with galactic civilization standards. The aliens would not directly interfere with human cultural expression, but would maintain oversight authority to prevent developments that conflicted with long-term civilizational stability. The agreement established monitoring and evaluation, procedures that would assess human adaptation to alien guidance and technological integration. Successfully meeting evaluation criteria would lead to expanded autonomy and eventual full membership in galactic civilization. Failure to meet evaluation standards would result in increased alien oversight and more direct intervention in human affairs. The arrangement was structured to incentivize human cooperation while ensuring alien objectives were achieved regardless of human preferences. Implementation began within weeks of the agreement's finalization. Alien representatives established coordination centers in major population areas, beginning the process of technological transfer and environmental restoration that would transform human civilization. The early results were remarkable. Alien energy technologies began replacing fossil fuel systems with efficiency and environmental benefits that exceeded human expectations. Environmental restoration projects initiated ecosystem recovery processes that had been beyond human capabilities for decades. Agricultural systems were enhanced with alien biotechnology that increased food production while reducing environmental impact. Water purification and atmospheric restoration technologies began addressing pollution and climate change with effectiveness that offered hope for planetary recovery. However, the social and psychological impacts of alien oversight proved more challenging than anticipated. Human institutions began adapting to alien guidance in ways that subtly altered traditional decision-making processes and cultural expressions. Educational systems were modified to include galactic civilization standards and knowledge frameworks. Scientific research was redirected toward areas compatible with alien technological integration. Economic structures began evolving toward resource allocation methods developed through galactic civilization experience. The changes were gradual but pervasive, affecting every aspect of human society in ways that preserved surface appearances while fundamentally altering underlying structures and priorities. Humanity was being transformed according to alien understanding of optimal civilizational development. Some human populations adapted readily to the new arrangements, embracing alien guidance as liberation from historical limitations and challenges. Others resisted the changes, viewing them as erosion of human identity and independence, despite the obvious benefits. The alien evaluation process continued throughout the integration period, assessing human adaptation and compliance with galactic civilization standards. Progress reports were transmitted to unknown alien authorities who would determine humanity's future status within the galactic community. By December 2028, as the first year of alien oversight concluded, humanity had begun a transformation that would fundamentally alter its relationship with itself and the universe. The environmental and technological benefits were undeniable, but the costs in autonomy and self-determination were becoming equally apparent. The alien presence had evolved from mysterious observation to active management of human civilization. What had begun as first contact had become the end of human independence and the beginning of supervised existence within a larger galactic order. Humanity had survived its first contact with alien intelligence, but at the cost of the independence that had defined human civilization throughout its history. The species that emerged from alien guidance would be more prosperous, more sustainable, and more technologically advanced than ever before. But whether that species would still be recognizably human remained the ultimate question that only future generations would be able to answer. The silent anomaly had completed its mission. 3i Atlas and its companion network had successfully evaluated, contacted, and integrated another emerging civilization into the galactic community. The process that had begun with mysterious observations had concluded with the transformation of an entire species. Humanity's cosmic childhood was over. Its supervised adolescence under alien guidance had begun. The universe had proven to be far stranger, far more populated and far more organized than anyone had imagined. And in the vast reaches of space, other probe networks continued their patient journeys toward distant star systems, carrying the same gift of survival and the same price of independence to civilizations not yet ready to discover they were not alone. The data refuses to behave, but sometimes the universe demands that we accept guidance from those who have traveled these paths before, even when that guidance comes at the cost of everything we thought made us unique. In the end, perhaps survival itself was worth any price, even the price of remaining human on our own terms. The silent anomaly had spoken, humanity had listened, and the universe would never be the same.